Good morning, students. Myself Shiv Shankar, Associate Professor, Presidency University, Bangalore. Today we are going to discuss about total internal reflection of light. What is total internal reflection of light? Whenever light is traveling from optically denser medium to a rarer medium, light gets completely gets reflected back to the same denser medium if the angle of incidence is more than the critical angle. Total internal reflection of light is a very important phenomenon and is having several applications today. We are using the total internal reflection in the fiber optic communication, wherein which the information is supplied in the form of light to the optical fiber, and this light travels through multiple total internal reflections, reaching the other end, and thereby we collect the information. It is also used in medical endoscopy. Now let's discuss the physics of total internal reflection. Now you see, uh, here we have a denser medium and a rarer medium, which is well separated by a interface. O is the point of incident for all these points. Now you consider the first case where the incident ray is in this direction and with the zero angle of incidence, and you all know that angle of refraction also becomes zero, therefore the light travels in this direction. Now consider a case where the angle of incidence is I. Here AO is the incident ray and OB is the refracted ray. You all know that when a light travels from denser to rarer medium, light bends away from the normal. Therefore, this is the angle of refraction which is greater than the angle of incidence when a light travels from denser to rarer medium. Now, let increase little more angle of incidence. What happens? You consider a case where light is traveling on the interface. Our angle of refraction is 90 degree. Now, this is a very important case. Whenever the light is traveling on the interface, or whenever the angle of refraction is 90 degree, that particular angle of incidence is known as critical angle. Now, if you further increase the angle of incidence, you can see here angle of incidence is further increased. In that case, light gets totally internally get reflected. This is known as total internal reflection of light. Say for example, here critical angle is say for example 42 degree. If you make the angle of incidence as 42.1 degree, light will get totally internally reflected. Now, there are two important conditions for total internal reflection of light. That is, this phenomena will take place whenever light travels from denser to rarer medium, and another thing is the angle of incidence must be greater than the critical angle. These are the two important conditions for total internal reflection of light to take place. Now let apply the Snell's law of refraction now. What is Snell's law of refraction, students? You all of us know the refractive index of the denser medium. Let us take it as n1, and the refractive index of the rarer medium. Let us take it as n2. Okay. Now applying Snell's law, we have n1 into sine of angle of incidence is equal to refractive index of the second medium, that is in this case it's a rarer medium, into sine of angle of refraction. Now what is important here is we'll apply this case. If the angle of incidence is equal to critical angle, then we know that the angle of refraction, then angle of refraction R is equal to 90 degree. So the very important, students, once again I'll repeat, critical angle is that angle of incidence wherein which the angle of refraction is 90 degree. That is how critical angle is defined. Now substituting this in the above equation, say for example you say equation 1, what we get? N1 into sine C is equal to N2 into sine 90. You all of you know sine 90 degree is 1. Therefore, we can rewrite this equation as N1 N1 into sine C is equal to N2. Or we can write sine C is equal to N2 by N1. Or you can also write C is equal to sine inverse of N2 by N1. Here you need to note one thing. N2 is the refractive index of the rarer medium. N1 is the refractive index of the denser medium. You all can understand that critical angle is inversely related to refractive index of the denser medium, and critical angle is directly related to the refractive index of the rarer medium. So friends, we have to understand one thing, that the refractive index of the denser medium has to be more to get the smaller critical angle. Why smaller critical angle? If the critical angle is smaller, you will get a much more magnitude of total internal reflection. That means what? If the critical angle is, say, for example, 25°, any light ray which is incident above 25°, it undergoes the total internal reflection of light. That is means 25 to 25 above to up to 90, all the light will undergo total internal reflection of light. This is very important. This is the same is the principle is applied in case of glass, in case of water. Whenever light travels from glass to air, whenever light is traveling from glass to air medium, or whenever light is traveling from water to air medium, or glass to water medium, these are the examples you can consider where total internal reflection of light takes place. Now we can work out some problems based on this, knowing the refractive index. Suppose, say, refractive index of the glass is, say for example, refractive index of the glass is, you take it as refractive index of the glass N2, let us take it as 1, that is for case of air, and refractive index of the denser medium, I'll take it here a glass, so 1.5. Refractive index of glass is 1.5, you know. So if you use these values in this formula, if you substitute, what you get? You get sine inverse of N2 by N1. N2 is 1 and N1 is 1.5. So if you work out this, what value you will get it is, so again you can write here as C is equal to sine inverse of 1 by 1.5 is going to be 0.67 or 0.667, and you get that value as, that value is equal to, you get C value is equal to 41.8 degree. 41.8 degree. We can rework it here. So I just take up this, I need some space here. Is the formula required? So we can understand now just a minute. So we'll work out now certain cases. We have derived the expression for critical angle. This is the expression for critical angle. This is the expression for critical angle we have. Now let me take the cases where first case I have first case one, let us discuss. I have a light traveling from glass to air medium. So glass means first medium is glass, refractive index is 1.5, and second medium is air, refractive index is 1. Let us consider. Now applying these values here, we get C is equal to sine inverse of 1 divided by 1.5. And you all know that you can work out 1 divided by 1.5 is, it is like 2 by 3. It is 3 by 2. Reciprocal of 1.5 is 3 by 2. 1 by 3 by 2 is nothing but 2 by 3. And you will get this as 0.667. And if you take the sine inverse of 0.667, what you get is critical angle is 41.8 degree. This is the critical angle for glass to air. Now let us also discuss for The case of In the case of diamond, let me tell you. In the case of water, also you can discuss. Say, for example, the light is traveling from water to air. So water means first N1 is first medium is water. So refractive index of water is 1.33, and the refractive index of the air is, you can take it as 1. N2. N2 you can take it as 1. N2 you can take it as 1. If you work out, what you get is C is equal to sine inverse of 1 by 1.33. And if you work out this sine inverse of, what you get is sine inverse of 1 by 1.33, you can take it as a 0.751, and this value you get it as something like 48.6. So this is the critical angle for water air medium. Now let us understand, in the diamond very large amount of total internal reflection of light occurs. Now let's understand what is the reason for to have a higher amount of total internal reflection in case of diamond. So this again I'll try to use it here. So therefore in case of diamond, you have refractive index of the diamond, it is 2.42. Let me use this portion only I want, and these values only I'll take it off. In case of diamond, we have refractive index around refractive index of diamond is 2.42. Okay, refractive index of diamond is 2.42, and whenever light is inside the diamond want to come out of the diamond to the air medium, so we take the second medium is air, and we have 1 divided by refractive index of the air is N2 value is 1, and N1 value is 2.42. So if you substitute 2.42 here, and you get it here 0.413, this 1 divided by 2.42 is 0.413, and sine inverse of 0.413 is, we'll get it as 24.4 degree. Very important, students. That means any light, any light which is any light which is incident above this angle up to 90 degree, all the light will undergo total internal reflection. That's why diamond is shining bright, because always you can see there is a good amount of light gets trapped, because any angle which is more than this will always be bounce back to the same diamond medium only. Only the angle which are less than this angle only escape out of the diamond. Okay, students, happy learning. Wait for my next lecture. All the best.